Welcome geniuses, I'm Genie, your best buddy for A-levels. In this channel, we'll bring you to explore the secret formula behind success.
Hi, this is the requested video. The topic is Poisson distribution. The subtopic is the binomial to Poisson approximation. Okay, the question is from May-June 2015, variant 7.2, question 7. In a certain lottery, 10,500 tickets have been sold altogether, and each ticket has a probability of 0.0002 of winning a prize. The random variable X denotes the number of prize-winning tickets that have been sold. Okay, part 1. State with a justification and approximating distributions for X. Okay, so first we need to know that a binomial distributions in the beginning, when it satisfies certain conditions, then it can be approximated as a Poisson distribution. With the mean, I use lambda 30%. So what are the conditions? First, the n is large. So how do you consider n is large? When the n more than 50. Second, the NP less than 5. Right? So we go back to the questions. So for these questions, as the X is denoting the number of prize-winning tickets that have been sold. So actually it means that is a binomial distribution because there is a 10,500 tickets sold. So the n is 10,500 and the constant probability to be 0.0002. All right. And we have the n equals to 10,500, which is more than 50. So n is large. Second, we look for the mean of the binomial distributions, which is NP. Okay, then we calculate this value is going to be 2.1. All right. And since 2.1 is less than 5, so we also meet the second conditions. So hence, with these justifications, the first one, the n is large. Second one, the NP less than 5. We can state the approximating distribution to be a Poisson distribution. All right, so that is answering part 1. Now, use your approximating distribution to find probability of X less than 4. So answering part 2. So since we are aware that the distribution should be approximated as a Poisson distribution, and the parameter is the mean, so which is 2.1. And now we are going to find the probability of X less than 4. So it means that we are going to find the probability of X is 0, 1, 2, and 3. All right, because it is less than 4, which means 4 is not included. And using the Poisson distribution formula, which is e to power negative of the mean, 2.1. Okay, so when the X is 0, so it's going to be a 1 here, right? Then when X is 1, so it's the mean 2.1. And then when X is 2, is going to be 2.1 square divided by 2 factorial, and so on. 2.1 cubed divided by 3 factorial. That is when x equals to 3. All right, so we just have to press calculator, and we can find out the probability to be 0.839, round off to 3 SF. Okay, so that is the probability for part 2. Okay, now we go on the part 3. Use your approximating distribution to find the conditional probability that x less than 4 given that x greater and equals to 1. So remember, in the statistic 1, we discussed about conditional probability, and the formula is given as this. A given B, which is A intercept B divided by probability of B. And they will use the keyword given. Right? The question here even mentioned that this is conditional probability. Okay, so we're trying to use this formula to answer the part 3. So in this case, we are trying to find the probability that x less than 4 given x greater and equals to 1. Right? So according to the formula, x less than 4 and intercept with x greater and equals to 1 divided by probability that x greater and equals to 1. Okay, so you need to consider what does it mean by this. We need to have x less than 4 and at the same time the x has to be greater and equals to 1. So it means we are going to find out the probability that when x equals to 1, or when x equals to 2, or when x equals to 3, right? So x greater and equals to 1, that's reasons why 1 is included, but x less than 4, so we do not consider 4. So that is the probability we need to find for numerator. As for the denominator, so since we are looking for probability that x greater and equals to 1, we are going to find 1 minus probability of x less than 1. Okay? So use the Poisson distribution again, since the question say using the approximating distributions. So the numerator probability e to the power of negative 2.1 for the 1, right? So 2.1. Then when x is 2, 2.1 squared divided by 2 factorial. And so on, 2.1 to the power 3 divided by 3 factorial. And divided by 1 minus the probability that x less than 1. And there is only one value, which is x equals to 0. So it's e to the power of negative 2.1. All right. So use calculator, we can find out the probability to be 0.816 round off to 3 SF. Okay, so that is the probability for part 3. All right, so that's all for this video. Please subscribe to the channel and like this video. I will see you in the next video. Bye-bye.
That's all for today's video. If you're interested in more genuine sharing by other geniuses, please subscribe to our channel and don't forget to turn on the notification bell, ding dong. Also, if you're struggling with 1 or 2 past year questions and the mark scheme just doesn't seem to help, Genie has got you covered. Feel free to let us know what question it is by filling in the Google form linked in the description below. GenieUs Hub will get genius teachers to fulfill your request for the solution. Genie will see you next time. Bye-bye.